Welcome to Get Your FRQ On. This question is from 2023. It's question 2, and it is calculator active. In the question stem, we are introduced to Stephen, who is swimming in a pool, and his velocity as he swims is given by a function v of t, and it's a rather complicated function, which is only workable since this is a calculator active question. In part A, we are asked to find all the times between 0 and 90 seconds when Stephen changes direction. Well, Stephen will change direction whenever his velocity is 0 and it also changes sign. Now, because this is a calculator active question, you can graph this function on your calculator and check that this only happens at t equals 56 seconds, where both of those criteria are met. So Stephen changes direction at t equals 56 seconds. In part B, we are asked to find Stephen's acceleration at 60 seconds, provide the units, and determine if Stephen is speeding up or slowing down at that time. It helps to make the explicit connection that when we talk about a of t, we are specifically referring to that as being the derivative of our v function. Since we're given a function v and we are not given an acceleration function, we should make this connection explicit. It's one thing, we've all done it. We know that in these contexts, a of t generally means acceleration, and that's the derivative of velocity. But you should probably explicitly state it just to make sure that there's a connection between the function you are using and the given information. Always good to connect those things. A of 60 would just be v prime of 60, which we can use a calculator to evaluate. A of 60, which is v prime of 60, is negative 0.036 meters per second per second. Now, to determine if Stephen is speeding up or slowing down at this time, we need to know the sign of v of 60. Remember, if v of t and a of t have the same sign, then we have speeding up. And if they have opposite signs, we have slowing down. We can use our calculator to determine v of 60. It's negative 0.160. And then notice that a of 60 and v of 60 have the same sign, so Stephen is speeding up at t equals 60 seconds. In part C of this question, we are asked to determine the distance between Stephen's position at t equals 20 and t equals 80. This is a fundamental theorem of calculus question. It's going to involve a definite integral. And what's interesting about this question is we don't actually have to know Stephen's position at any point in that interval. Right? Remember that the definite integral will just tell us the change in displacement or change in position over that interval, and that's all we're asked to find. We're not asked to find Stephen's position at t equals 80 or at t equals 20. We're just finding how much difference there is. So we can do this using our calculator to calculate the definite integral from 20 to 80, right? And then whatever that is, that's the change in or the total distance between his position at t equals 20 and t equals 80. All right, so the integral from 20 to 80 of v of t dt is the integral from 20 to 80 of this big nasty function with an exponential and a trigonometric function. But it's a calculator active question, so we're going to use our calculator to do this, and it turns out it's 23.384 meters. In part D, we are asked to find the total distance from 0 to 90 seconds that Stephen swam. Total distance, you may recall, is a different integral. We have to integrate the absolute value of our velocity function. So between 0 and 90, we're going to integrate the absolute value of our v function. Using a calculator again, it's calculator active. That turns out to be 62.164 meters.